In the mass spectrum processing method, there are a number of parameters that can be changed to increase or reduce the number of biomolecules identified from the deconvoluted data. This video will explain how those parameters are used. The first step in processing each mass spectrum is to identify all potential peaks. This is done by considering each data point in the spectrum that lies above the peak picking threshold, which is expressed as a percentage of the maximum abundance in the current spectrum. Increasing the peak picking threshold will reduce the number of peaks found. Consider this part of a deconvoluted mass spectrum. We can see perhaps 3 peaks in this spectrum. Let's apply the peak picking threshold and consider each data point in turn. As we work our way across the spectrum, we find that the first 4 data points are below the threshold, and so we can ignore them. Once we find a point above the threshold, we will continue until we find a point with a local maximum response, and we label that point as a peak apex. We repeat this process until we have considered all of the points in the spectrum. Using this approach with the data shown, we have identified 2 peaks for further processing. Let's focus on the first one. The 2 remaining MS processing parameters are now used to find the start and end of the peak. First, the peak height for centroid value is applied. In this case, we've selected 50%. Next, we note the max steps from peak apex value. In this case, it is set to 5. Starting with the apex of the peak and working to lower mass, the process identifies the first point below the threshold as the start of the peak. The process used less than 5 steps, so this point is marked as the start of the peak. The same process is then applied from the peak apex with increasing mass until the peak end is identified. Here we see again that the point was found below the threshold without reaching the maximum number of steps. The final part of the process is to calculate the height, area and centroid of the shaded polygon that represents this peak, and to store these values for the centroided mass spectrum. Once this process is completed for all peaks, the filter options can be used to reduce the number of peaks that will be included as biomolecules when the results are saved. The list of peaks can be limited to a maximum number, or can be reduced by specifying a height or height percentage threshold. All of these parameters can be saved in a method that can be reloaded later.